I currently work on Adobe. My title is Platform Security Strategist, and basically what I do is I help the Flash Player team devise security strategy from everything from creating new security features that can help developers to securing the internals of Flash Player. But one of the other things I work with at OWASP is I work on the Flash Security Project, which is something I work on in my spare time to provide and consolidate the resources that are available to the OWASP community with regards to security research with Flash Player. So I'll be talking a little bit about both of them. We're going to start off with a quick introduction to Flash Player. I know most of you probably already know what Flash Player is, but there's some details which are important about understanding Flash developers that will help you better interact with Flash developers within your organization or when you're consulting for a company that has a Flash development team. We'll go through finding some example Crosssite Scripting vulnerabilities, taking a look at Flash from a source code point of view, taking a look at how Flash interacts with servers, and understanding that Flash is a part of an overall web application. So it's important to understand how Flash content interacts with the server on their server side. We'll talk a little bit about cross-domain policies. I'm not going to spend a lot of time on it because I have another talk tomorrow that's all about cross-domain communication. So if you're interested in the cross-domain aspects, I'd recommend showing up to that one. But for people who are watching this video later and for people who can't make that talk, I'm going to talk a little bit about cross-domain policies here. So the first thing you need to understand when you're thinking about Flash players, you have to understand that there's two core sets of developers that work with Flash content. They're essentially designers and engineers. A lot of times Flash is used for animations, for advertisements, for Flash games. And the people who tend to work on those tend to be designers. They're not computer science majors. They were people who were digital arts and new media majors. They're people who understand UI design, how people interact with content when it attracts their eye, how to arrange SWIFTs in the context of scenes and frames and putting together a SWIFT part by part to make an overall application. And it's very different from people the other side of the Flash development community, who tend to work on more complex Flash applications. Things that involve forms, things that involve websites, maybe it's a tabbed UI. Those people tend to be a little bit more structured, and so when you're talking to them, it's easier to talk to them in the language of computer science because they were probably a computer science major, a computer science minor. They've taken a couple of programming classes outside of just Flash, and so they have that frame of reference. So if you're talking to someone who's a designer, they know terms like inverse kinematics, which is not something that your average security person has to understand, whereas an engineer would understand object-oriented programming and inheritance and those types of terminology. So it's important to sort of understand what type of Flash development you have going on in your organization. A lot of times for things that are animations or design-based, the SWIFTs come in from actually outside the company. They're driven by marketing campaigns, and the people are hired externally, and the content is brought in. And it's important to understand that when you're thinking about the security of your web application as well, because a lot of times when people go and they contract with these smaller design shops, they forget details like getting a copy of the source for the SWIFT in case you guys have to do updates to it later. Also, the design shops don't necessarily have a foundation SDL, secure development lifecycle type programming. They focus on what they do best, which is create animations, create games, create interactive content. So it's important to understand where the SWIFTs came from and what their purpose is within the overall web application. Another thing that relates to that is sometimes you hear the term flex, and people get confused between what's Flash and what's Flex. And that again comes from the fact that Flash Player serves two different types of development communities. There's a authoring tool known as Flash Professional, and that's the tool that helps designers create their animations. And again, it works on scenes and timelines and frames, and the terminology that someone who's doing an animation would understand. With Flex, Flex is geared more towards the engineers. They're actually writing the application in an XML-based language. They're using ActionScript much more heavily. But at the end of the day, both of these just get compiled down into Swifts. They both get transformed into bytecode. So when you hear Flex, it just has to do with how it was authored, the way that the person went around authoring the Swift. But at the end of the day, it gets compiled into the same bytecode. It gets run through Flash Player the same way. So it's important to know the language because you can tell them which APIs they should be using. But in terms of doing like a black box penetration test, it's not going to make a difference to you whether they used Flex or Flex Builder or if they used Flash Professional. Actually, I should say Flash Builder because it's Flash Builder now. When you look at Flash, Flash is able to interact in a lot of different ways with both the web application and the end user. So there's a lot of different communication paths that Flash can take. It can talk to HTML on its own server. It can talk to a CGI on another server. One Swift can load another Swift as a child. It may be storing local shared objects to store game states or what your volume level is at YouTube. And if you're using it for teleconferencing, you can also access the camera and microphone. So there's a lot of things that can go on in the Flash world that might be of interest to the security professional. But at the end of the day, a lot of this can get summarized down into basically 3 basic concepts. By default, Flash Player will enforce the same origin policy. We don't try to break the web browser security model. We enforce the same origin policy, and we try to give consistent behavior that you would get with the web browser. In places where we do allow the content to extend itself past the same origin policy or past the browser, and what the browser typically does, in those cases, we have opt-in controls. They're either allow script access or they're cross-domain policy files. But in order for Flash to go beyond that, there's usually an opt-in control in its place. And for things that don't concern the server, but instead concern the end user, we'll prompt the user. So for instance, enabling camera and microphone access. There's actually a 50-page white paper that describes the security model in detail. If you're interested in knowing the very details of the security model, you can take a look at that. Also, if you prefer watching videos, Dean Makeda, who's one of the Flash engineers, did a presentation at Max on the Flash security model as well. And as far as these links go, all of these links are available on the OWASP Flash security project. So everything I pretty much reference in here, you'll be able to find there. So you don't have to worry about copying down URLs exactly. You can, if you remember the OWASP Flash security project and know roughly what I was talking about, you should be able to find that information there. So let's start with the very basic of Flash. That's web page permissions. So whether or not a Swift can talk to its surrounding container, whether it can talk to the HTML that has loaded it, all depends on what the allow script access setting is that was set on the object tag. So by default, Flash can only talk to the HTML and talk to the JavaScript DOM if the Swift and the HTML page were hosted on the same domain. If they came from the exact same server, they're allowed to talk to each other. It's assumed that it's part of the overall web application. If an HTML on www.example.org is loading a Swift from images.example.org, by default, they will not be able to communicate because those are 2 different domains. Flash Player matches on the fully qualified domain name. But you can override that. And this is one of the areas where we have an opt-in control. And you can set allow script access to always, and that will allow the Swift on images.example.org to talk to the HTML and the DOM of www.example.org. Now, there is an allow script access setting of never for different reasons. Flash players decided to deprecate that, so you will see in our documentation, but it should be listed as deprecated as a setting. Now, sometimes you're loading content from a remote domain and you don't want to be able to interfere at all with the surrounding web page. You don't want to be able to even create a new pop-up window. If you're in that sort of situation, for instance, let's say you're Facebook and you're loading a video player from YouTube, and you want the YouTube player to be able to play the video on the Facebook homepage, but you don't want it to interfere with the user's experience. You don't want it to be able to redirect the user somewhere. You don't want to have it through a pop-up window. You just want to be able to let the video play. In those scenarios, you can actually set more stringent HTML parameters, and you can set a parameter known as allow networking. And if you set allow networking equal to internal, that prevents the Swift from even being able to do browser navigation. So if you've got a Facebook page and it's playing video from the YouTube, a video from YouTube, the YouTube Swift won't be able to create a new window, won't be able to redirect the current window. All it can do is sit there and play. It's allowed to call home to its home server. It's allowed to load data. It's allowed to get the video from YouTube, but it's not allowed to actually interfere with the behavior of the web page. And then there's allow networking equals none. And basically that just shuts the Swift off so that the Swift can only do what's ever compiled within the Swift. It can't talk to any servers. It can't call home. All it can do is whatever it was programmed to do and was shipped within that original Swift file. So allow script access is a superset of allow networking. If you set them both within the object tag, whichever one's more stringent will take effect. And so the object tag, or I'm sorry, just to give you a visual representation of this and how this affects even more complex setups. Let's say you have a Swift called friend.swift that you're hosting on your website. It's www.example.org. And that Swift, as a child, loads another Swift from fo.com. It loads it from an untrusted source. So you have a parent Swift, and that parent Swift has loaded another Swift as a child. If you have allow script access set to the same domain, the one that was hosted on your domain will be able to talk to the web page. The one that was loaded as a child of the parent will not, because it was loaded from a separate domain. Now, if allow script access was set to always, then this Swift would be able to actually talk to the loading HTML. Yes?
Is there anything in between where you could say, I don't want everybody in the world to be able to talk to the DOM, but I want these domains to be able to talk to the DOM?
Not right now. Right now, it's an all or nothing setting. It's either they came from the same place or they didn't come from the same place. So it's either same domain or everyone in the world right now. We don't have that level of refinement right now.
So,
yes?
So when you set this, like this particular setting is being set when you are on a website, or it's a universal setting on your machine?
No, it's set by the HTML that's loading the Swift. So here I have some HTML. It's a standard object tag that you would see within an HTML page. The first two lines are just the setup for the object tag, which tells the browser which plugin to load for this content, what the ID is for it. And then as parameters within the object tag, you can set allow script access, and you can set allow networking. So the web page which is loading the Swift is making a statement that I trust this Swift to talk to my DOM, I trust this Swift to manipulate my HTML, or I don't. And that's what the permissions are basically all about. Yes?
I believe the browser same origin policy takes into account the port and protocol as well. Does that apply for Swift?
I believe we take into account the protocol, but not the port. I have that on another slide in tomorrow's presentation, but off the top of my head, I don't believe it takes into account the port. I can double check that for you. So those are the basic HTML page, parameters, which gets the Swift loaded into the browser and gets it running. A lot of you probably do web application penetration testing, or you help test the websites for your clients. So we can talk a little bit about cross-site scripting. Since Swifts have various functions, there are certain types of Swifts which tend to be more likely to have cross-site scripting than other types of Swifts. If you see an advertisement which has a flash bar called click tag, a lot of times that's a good one to test, because there's click tag is a URL that the Swift is supposed to navigate to after the person clicks on it. So if someone clicks on the ad, it tells the browser where to go take the person for clicking on the ad. Typically, those tend to have cross-site scripting in them. Swifts that load XML configuration files tend to have cross-site scripting opportunities in them. Mike Bailey presented at Black Hat DC